Shubhendu.
Okay. Good evening, ladies and gentlemen. I am Shubhendu Parth, consulting editor of Voice and Data, and your host for today's online dialogue on delivering on the promise of adaptive IP. It's my pleasure to welcome you at this live webinar on an important topic that is close to the heart of everyone engaged in network and IT infrastructure planning. The webinar is hosted by Voice and Data, India's oldest telecom magazine from Cyber Media Group, along with Ciena. While we always knew that digital transformation and cloud were the way to go forward for enterprises and economies, the development during the last 4 months have kind of accelerated the process. As we know, the networks are continuing to scale, more so in the new normal, and there is a never-ending demand for more bandwidth. This has also led to an avalanche of data that needs to be collected, analyzed, and acted upon, and not to miss the security aspect. This makes it essential for a network to evolve. The question is, how do we do this? Do we add more hardware or hardware-centric platforms? Or should we deploy large and complex boxes? Okay, let's not discount the traditional approach and solution, but as we move toward more complex digital and mobile-centric business approach, we might need to start thinking more pragmatically. I mean, how quickly can we scale up our network without increasing the complexities by 2x or 3x and expenses by the same ratio? Or is there a better way to make our network more flexible and adaptive to changing needs and emerging digital business models? In other words, what do we really need to do? A highly scalable and cost-efficient solution that can make my life simple while helping in expand IP capabilities to the network edge. An organization also needs easy tools for network optimization and real-time visibility. Am I right? We will hear about all this in today's session, and to share the insight, we have with us Mr. Brian Lavallee. Brian is a Senior Director of Solution Marketing with Ciena. He's an industry veteran with more than 20 years of telecommunication experience and with expertise in packet and optical networks, access to submarine networks, and everything in between. We also have with us Mr. Nihar Panda, who heads Ciena's India Business Development and Solution Architecture for Blue Planet Network Automation Solutions. Nihar has been in the telecom industry for more than 20 years, and he has worked with multiple NEPs, OEMs, and operators in multiple technology leadership roles, primarily in the area of IP, SDN, NFV, automation, and cloud. Now, before I hand over the session to Brian, who will be sharing the market dynamics and adaptive IP overview, I would like to just point out to some housekeeping essentials. For the duration of the presentation, the participants' line will be on a listen-only mode. After the presentation, we will have a question and answer session, and the participants will be able to send us their questions through the chat, and we will take it up during the slotted time. It's also important that we get your feedback, so please don't forget to submit your feedback at the end of the webinar. During the presentation, to make it more interactive, we have a couple of polls, which the respective presenters would be taking forward. So over to you, Brian.
All right, quick sound check. Can you hear me?
Yes.
Excellent. All right, so let's get started. As was just explained, we're going to look at delivering on the promise of adaptive IP, and I will be speaking with my colleague Nihar. And we broke this presentation up into 2 sections. So I'll be covering more of the business side of the market dynamics. What's driving the need for a new way to deliver IP connectivity? So IP is the glue that holds the global internet together, and it has not been really changed or modernized for a long, long time. So there's a lot of new technologies that have come to market over the last, I would say, 5-6 years. And we're going to talk about how can we leverage those technologies to deliver standards-based IP, but in a different manner. So I'll talk about the market dynamics. I'll talk a little bit about the adaptive IP solution itself. What is it? And why we believe it's the better way to deliver IP networks. And then I will pass it off to Nihar, and he will talk about segment routing with Blue Planet automation. So he'll be diving a little bit more into the technology. So we're trying to give here a business and a technology overview. But let's get started. So here we're going to talk about the market dynamics, and then I'll give you an adaptive IP overview. What is it, but also what it is not. So I talk to a lot of operators around the world, network operators, and these are network operators who operate very small networks to tier 1 operators. It includes, your basic tier 1, tier 2, tier 3 service providers providing IP business services, cloud. Even in North America, the cable MSOs with their fiber deep initiative, they want to move fiber deeper into the neighborhoods, but also the mobile network operators. And when we think mobile network operators, everybody thinks 5G. And 5G is the next evolution of mobile networks, but it also has a huge impact on IP networks and also how IP networks need to be designed and deployed. So when I ask the operators, what are the 3 biggest issues that are keeping you up at night? What are your 3 biggest business challenges? The first one is new and emerging technologies. They're requiring layer 3 much closer to the edge. And what I mean by the edge, typically at the edge of the network, it was mainly layer 2 based, so Ethernet based. But a lot of that has changed, and layer 3 connectivity and functionality is being pushed to the edge of the network. And as everybody knows, in the networking world, as you get closer to the network edge where content is consumed and created, right? So we're talking towards residential, business, and mobile sites, the amount of nodes increases exponentially. And with 5G, IP connectivity, not only for the macro cells that we have today, but also the order of increase in magnitude of small cells with 5G is just going to increase the amount of IP nodes that have to be managed. So a lot more nodes to be managed, and this leads to a lot of complexity. The other big one is here, and this is across the industry in general, is over 300% traffic growth from 2017 and out to 2022, which is just a couple of years away. This traffic growth is good for the industry. The more bandwidth that we allow customers to have access to, the more they use it. We always find a way to use bandwidth. The issue for the network operators, though, is even though there's over 300% traffic growth, in most areas of the networking industry, there's flat to declining revenues and margins. And the CapEx and OpEx that the network operator can spend is directly linked to how much revenues they have. So even though traffic growth is increasing, the amount of revenue per bit is actually going down in many areas. And this is one of the biggest issues that's challenging network scaling using traditional architectures. There has to be a better way to build IP networks that can lower the operating costs. So even though the revenues are flat to declining in some areas, we can still protect the profit margins by lowering the cost of the network. And this, is enabled using such technologies as automation, which we'll talk about today. And then lastly, the legacy approach. So as these networks continue to grow and scale, we're looking at a lot more IP endpoints in future networks. 5G and mobile networks and small cells will represent a very significant part of these new IP nodes, and also the whole Internet of Things, where each machine will have an IP address connected to the network. So we have an increase in IP nodes, we have an increase in traffic growth, and the legacy approach of just continually throwing more and more bigger routers at the problem is just not scaling anymore. It's just not a cost-effective way to build out IP networks. But there's also IP protocol bloat. And what I mean by bloat is there are 50 plus protocols related to IP. So IP is just 2 letters, but it actually entails 40, 50 plus protocols that are associated with delivering IP connectivity. Many of these protocols have not been updated in decades. Some of them are not used anymore. Some of them are obsolete, but they're still sitting in a lot of the routers that are being deployed today. So why would you have all these IP protocols in your network that you don't need? They have to be managed and maintained. And from a security perspective, if you have an IP protocol in your router that hasn't been updated, the software code because nobody's using it in decades, it represents a security risk in your network. So all of this legacy approach of just continually throwing more routers at the problem and each router containing more and more IP protocols, it has a big increase in operational complexity, and that impacts everything from a business perspective. So that impacts the CapEx and OpEx that you have to spend to maintain these increasingly complex networks, but it also greatly affects your time to market and your time to revenue. So these are the three biggest issues that are facing the network operators today. And it's more IP endpoints, it's an incredible amount of traffic, it's increasing complexity. So there has to be a better way to build networks, and this is what we're going to cover today. So if we look, we're going to look a little bit in the past, and then we're going to look towards the future. So if you look at yesterday's way to deliver IP connectivity, it was very much designed to scale clients. So we're talking devices and nodes, basically routers. And these IP networks were very hardware centric. It just means put more and more routers in the network, add more and more protocols, have the routers communicate with each other, and somehow it all worked. Now, this isn't to say that it doesn't work. Obviously, it works because the global internet is pretty reliable and resilient. There just has to be a better way to build standards-based IP connectivity. The integrated control and data planes, the software innovation. Once you tie it to the hardware from the same vendor, you're actually tied into that vendor's innovation cycle. So if you want advances in hardware and software, you are limited to one vendor, and that's the vendor that you chose your router from. They are proprietary in many cases. There's been tweaks to some standards-based protocols, so that does cause some interop issues. Most operators I talk to now will only accept open standards-based networks, and that's because they want to have a broad vendor ecosystem. And the only way to do that is to have open standards-based connectivity, so you can mix and match different networking solutions and devices and technologies from different vendors. And I mentioned this earlier about some of the legacy protocols. Right now, in most routers in a traditional architecture, there's just simply too many obsolete and unnecessary legacy protocols. If you're not using them, they should be pulled out of your network. That has a big impact on the simplicity of your network, but also on the security of your network. And in yesterday's IP networks, the legacy way of building IP networks, the success metrics was very much around speeds, feeds, and protocols. So the best router was seen as the one that had the fastest port speed, the maximum number of ports, and also supported the most protocols. And I think that's an archaic way of looking at building IP networks. So all of these attributes of a traditional IP network results in increased complexity. And that's the biggest problem facing most operators around the world, complexity. That leads to time to market reductions in the speed, in time to market and time to revenue. It also means that if you want to go after a new business opportunity, it's much harder to do because your network is so rigid and complex, it's hard to adapt it to a new business case and a new business opportunity. So this complexity is a big part of the reason why operators are asking for a different way to build networks. And with that complexity, increased processing, the more protocols you have running in your network, the more processing power you need, and processing power leads obviously to storage and footprint. Bigger routers consuming more electricity and power, they need more compute, they need more RAM, memory. So everything here is interrelated. And then lastly, also the power consumption, which is becoming a big issue. I saw a study years ago from Greenpeace, and they were saying that if you took all of the data centers in the world and you added up their power consumption, they would be the 6th largest country in the world. So power consumption is a big issue. It's an ongoing OpEx for most operators around the world in all parts of the network. So if you can end up having a much more cost-efficient network, that impacts your bottom line, which is what everybody's looking for. So if you look at these 5 attributes of network complexity and what they mean to the operators, from a business side, this results in more OpEx. The networks are very complex. They're very hard to set up. A new service, it takes a lot of time. Very often it's manually intensive, but it also means a lot more CapEx. You're putting bigger and bigger routers into your network. Not only do the routers cost a lot, but also the power consumption and the space requirements for these routers also has a big impact. And then lastly, I think the bigger impact that the operators are seeing, the operators obviously are in a hyper-competitive environment against each other, but they're also competing with the internet content providers as well. So they have a new competitive space that's opened up. and they're up against some pretty big heavyweights. So the business impacts on agility and performance of having an overly complex network is something that the operators need to reduce or even outright eliminate. So this is yesterday's way of building IP networks. It does work. It has worked for many decades, which is a good thing. It's just the networks have changed. Use case and applications have changed. The business dynamics have changed. The competitive landscape has changed. There just has to be a better way to deliver open standards-based connectivity. So if you look at the networks of tomorrow, how can we build a better IP network? Well, now instead of just scaling clients and nodes, meaning putting more routers with more ports out in the field in the networks, we're looking at more resources on demand. So we're looking at a cloud-like type of environment for IP connectivity. Today, if you want compute and storage, you can go to any of the large data center operators or the web service operators. Amazon Web Services is a good example. And just with a credit card, you can spin up storage and compute. And this is what the world wants in terms of the network. We want to have that same level of cloud-like capability and on-demand performance of turning up IP connectivity when and where it's required. And to do so, you have to have very much a software-centric network design rather than a hardware-centric design that we have today. And software-centric, we're talking here about SDN, software-defined networking. And once you have that software-centric network design, then the innovation moves from hardware to software. And this allows you to do a lot of things in a much quicker manner. It enables flexible and agile topologies and architectures, but it also allows for a disaggregated control and data plane, meaning separating the hardware from the software. And what this allows you to do is have different vendors for your hardware and software, and then you can have two innovation cycles, one for hardware, one for software, and it also opens up a whole new and broader vendor ecosystem. But you also want a leaner set of supported protocols, and these are existing protocols and new protocols. So you can look at your protocol stack in software and you can decide, these 10 protocols, I don't use them in my network, I've never used them in my network. Why are they in my network? And by having a leaner set of IP protocols or leaner set of protocols to support IP, you're able to have a much simpler network. And that's the first step of making your network simpler, is to take out the protocols that you don't need, the ones that are obsolete or unnecessary or just not required by your particular network, but also leverage some new technologies like segment routing, which also takes out some of the more complex and chatty protocols in your network. And we're going to talk about that in a lot more detail in this presentation. So now the success metrics have moved from, who has the biggest router to agility, simplicity, and usability. It's about turning up network services very quickly and getting to revenue very quickly. And it also allows you to differentiate on speed, not just connectivity. One of the reasons why I mentioned earlier that the revenues are flat to declining in many areas is because of hyperconnectivity. And for the most part, the services look very similar to the end users. So if you can compete on speed or time to market, you can actually beat your competitor. Even though you have the same type of service, 100 megabits business service, for example, you can compete on speed to market, where you can turn up a service in minutes rather than weeks to months. And that's the biggest advantage of having automation and a simpler network that's programmable and open. So how do we do this? Well, the industry is focused on automation. So automation on the ICPs, the internet content providers, and here we're talking about Google, Facebook, Microsoft, and so on. Their internal networks, they have a lot of software developers. They've been automating their networks and using software-defined networking for many, many years. And within their data centers, this is how they are optimized. Now, the networks that interconnect the data centers can also benefit from the same type of intelligence and automation. And that's one of the key technologies that the networking industry is starting to adopt is automation. Second is open. The more open your network architecture is, the broader your vendor ecosystem is. So if I'm a network operator, I would prefer to have a choice of 3 to 4 vendors rather than just one vendor where I'm locked in. And that's where closed or proprietary tend to be dirty words in our industry right now. And there's a lot of drive and push to open up the networks. And we see that in the submarine space, where we now have open submarine cables, all the way into the radio access network, where we have open RAN initiatives and several other groups working to open up all parts of the network and even opening up the coherent optical space as well. So if you're going to build your next generation IP network, you want it to be very much open. And open gives you a whole bunch of benefits. Broader supply chain, it's more secure, increased competition among vendors, ultimately leading to lower costs. solutions, and that ultimately leads to a better bottom line if you're a network operator. And then lastly, a lean IP protocol stack. So let's just use the protocols that we need. We don't need to support all the ones that haven't been used in decades, and we can have a much leaner protocol stack. And by doing so, I mean the main benefits of having a lean IP protocol stack, it takes out a lot of complexity and operational expenditures out of your network. And that's one of the key benefits. Now, if you can roll in segment routing, which is a new way to do routing over MPLS networks, that just adds another layer of simplicity because you're removing even more protocols. I'm talking RSVP, TE, and also LDP, and Nihar is going to talk about that. So once we have automation open and lean, as long as these networks are based on some of the key technology trends that we're seeing, such as segment routing, which we'll talk about in more detail today, real-time telemetry. So who better than the network to tell you what's going on in the network? And by having real-time telemetry, you can actually get a snapshot of the health of your network, but also the asset utilization across your network. And this allows you to make more informed decisions, and we'll talk about that. Data-driven analytics. So analytics and intelligence, this drives software automation. Better automated decisions are made when you have data-driven analytics, and these two are tied together. And we're going to talk about this on the closed-loop automation slide. And then also programmable optics. We're talking IP connectivity here, but you still have to cross an optical layer to get the bits from one node to another and across the network. So even though we'll have a software programmable IP network infrastructure at layer 3, we'll also have a programmable optical layer below it. And by combining from layer 0 up to layer 3, this allows you to build a much more optimized network, because now you can optimize across multiple layers. Some optimization is better done at layer 3, some is better done at layer 2 or 2.5 with MPLS, for example, and some is done at layer 0. But to be able to make the optimization decision at what layer, you have to have visibility across multiple layers. So this leads us to what Ciena calls the adaptive network. And this is our vision or framework of the network of the future. And it's all based on closed loop automation. So the way we look at the network is going beyond just the routers. So the routers obviously in an IP network are important. They're the ones routing the packets from one end of the network to the other. But there are better ways to make the traffic management decisions, and also the traffic setup and teardown, but also the assurance as well. So we're going to look here from the bottom right, so programmable infrastructure. And what this provides you is the connect part of your network. So this is how you actually connect your network together. And this is a dynamic pool of physical resources, but we're talking about software-defined networking and NFV at the same time, network function virtualization. So now it's a dynamic pool of virtual and physical network resources. And they're highly instrumented, means they can give you real-time telemetry, which you can see here. But they're also open, scalable, and secure. So this is the connect part of the adaptive network. And this is the streaming telemetry that you see here is providing real-time telemetry data of the state of the network, and it's sending it into the analytics and intelligence part, which is the sense part of the network. And this is allowing for predictive analytics and also machine-based learning on both big data and small data. So once we have that real-time snapshot of what's going on in the network, and this could be, the health of the network, it could be the traffic profiles, who's connected to who, you can take that data, feed it into the machine learning algorithms, and you can come up with actionable insights. And this is, if you have one part of your network that is oversubscribed and another part of your network that is undersubscribed, machine learning by using real-time data will provide you with that actionable insight. Now, the intent-based policies that you see here is because the software control and automation, you can do this manually, you can do this in a fully automated manner, or you can do this in a hybrid manner, where some of the decisions are made by the network itself, and some of the decisions are made by a human who has to click the "Are you sure" button, okay, and then the automation acts upon it. Now, the software control and automation, this is with federated inventory and also open domain control and multi-layer orchestration. So this is the part of the adaptive network that actually does something. It acts, right? So it'll actually turn up a service. It'll reroute traffic. It'll route traffic around a transmitter that is showing real-time telemetry data of impending failure in the future. So you can reroute traffic around that port, for example. Does not affect the customers. You can swap out that card, put in a new card or a new pluggable, and then the network will sense that it's up and running, everything is good, and then that resource is available again to be reused. Now, the multi-layer orchestration, this is critical because I mentioned earlier, the best way to optimize the network is to have visibility from layer 0 to layer 3. And then you can decide through machine learning and analytics, what is the best layer to perform that optimization task on. And to be able to do so, you have to be able to see all three. Now, what you see here is connect, sense, and act. And this here is closed loop automation. It is strictly driven by intent-based policy. So the network can't do whatever it wants, right? The network will only do what you allow it to do. So some tasks may be automated, some tasks may not be automated. You want a human to stand in and review what that actionable insight is. Do you really want to reroute traffic around a certain node? You know, you may want to have your operations team review the insight first and then trigger that automated task. So it's very much dependent on the operator. And then you have technical and professional services. So if you want to implement such a vision and architecture, right, you have a variety of technical and professional services that help you not only design and build your network, but also operate it. And the goal here is to improve the agility, the speed, and the optimization of your network for a far more cost-effective network that is very quick to address changing business challenges and opportunities, but it's also a lower overall cost network to operate because you're optimizing at all layers all the time. So what is adaptive IP? I talked about adaptive network, but what is adaptive IP?
So, Brian, can I just interrupt before we, you start defining that? May I request that we take a poll?
Sure.
If that is okay with you?
Yes, absolutely. Yeah. So the poll
here is the poll for the panelists. Yeah.
Yeah, the poll question here, and thanks for reminding me. I think I might have jumped over it. Which is the most important part of your IP network of tomorrow? So you have three choices here. One is intelligent automation based on real-time streaming telemetry. The second one is open network architectures that allows you to pick and choose which vendor you want in your network, which products, which technologies, or a leaner IP protocol stack that results in a simpler and more cost-effective network to own and operate. So we're going to give you just maybe 30 seconds more to review these three. So basically your choice is what's more important to you in your network? Is it automation? Is it an open network architecture? Or is it to slim down the amount of protocols that are running in your network to decrease the complexity and improve your time to market? So please select your choice. And let's see what the poll results are. Automation, yeah. So automation, that's actually kind of not surprising to me. Most operators I talk to, automation is the big topic of discussion. So that makes a lot of sense. Second, the open network architecture, of course. This is also very important as well. An open ecosystem, better vendor selection, and also the lean IP protocol stack. So I'm not surprised this one comes up third. It is something that the operators are spending more and more time looking at. And this is very much, when you get to a point in your life when you want to downsize, you start to look at your network, and the best way to simplify it early on is to remove the protocols out of your network that you don't use or you don't require. And once you've done that simplification, then you can look at other types of technologies such as segment routing, which we're going to cover today. So thank you for the poll results. And we have a couple more polls with Nihar, so we'll continue here. So what is adaptive IP? I talked about adaptive networks. This is closed loop automation. This is a programmable infrastructure. It's analytics and intelligence and software control and automation. With adaptive IP, it's a very specific use case of the adaptive network. So we're using the three technologies or the three pillars in the adaptive network wheel on the previous chart. And this is very specific to delivering IP connectivity. In the case of Ciena, we're talking about IP connectivity from access to metro. And we've designed a solution very much around leveraging closed loop automation to deliver IP connectivity for a certain set of use cases. The primary ones are 5G, which is all the rage today across the world, IP business services, and also next generation access and cloud connectivity. So adaptive IP is a use case of the adaptive network specifically to deliver IP connectivity from access to metro. So we're going to talk a little bit here about what it is and what it is not. So what is not IP? So adaptive IP is not just about another router, right? There's a lot of router vendors in the industry today. This is not just another router. What we wanted to do was leverage, look at the network holistically, not just at the network, at the node level or the router level. We wanted to look at it from an end-to-end network perspective. So how can we improve the network efficiency and cost effectiveness from end to end? And that's across all layers as well. So if we just wanted to build another router, it'd be pretty hard to optimize from or get significant optimization and cost reductions out of your network. What we wanted to do was leverage some of the other technologies here. And you can see here, these are the Blue Planet products we have, and Nihar is going to talk more about this. It's to leverage software control, automation, streaming analytics, machine learning, artificial intelligence, and of course, the programmable routers. So the routers are still important. You can see here on the bottom, these are some of the routers that we have in our portfolio, but it's also leveraging the open APIs. And once we have an open application programming interface, we can plug into the application sitting on top, and that gives us the analytics, intelligence, and software control. And that's the big difference here. So adaptive IP is not just about the router itself. These are standalone routers. They can work by themselves like any other router in the industry. But once you tie in the Blue Planet software automation portfolio on top of it, now you're changing the network. You're not just putting in yet another router. And this is a key differentiation. So we talked earlier about legacy IP connectivity, very much hardware centric, rigid in design, very heavy on the protocol stack. And when you wanted to increase the scalability of your network, more and more users online, consuming more and more traffic, but also 5G is going to result in millions more IP endpoints around the world. This legacy way of delivering IP connectivity is just not a cost-effective way to do so. So what Sienna's adaptive IP does, it leverages very much an open software-based infrastructure and architecture. It's very flexible and agile because it's SDN based. It uses software control and automation, open APIs, machine learning, artificial intelligence, streaming telemetry. So it really does look at it holistically across the network. Now, one key point to look at here is the artificial intelligence, machine learning, the software control and automation, and all the other parts of our Blue Planet software portfolio does work with Ciena gear for sure, but it also works with any other third-party vendor that has an open API, or if it has a proprietary command line interface, for example. We do have things called resource adapters where we can translate a closed CLI or command line interface to be able to talk to our software automation suite. So what is adaptive IP in terms of the three pillars? We very much level an open architecture. We allow customers to mix and match, pick and choose what they like from our portfolio, but also what they like from other vendors' portfolio, because we do recognize at Ciena that no one vendor is going to provide an end-to-end network solution across all layers. It's just not realistic, and it's just not feasible. So our entire architecture from the programmable infrastructure layer right up to Blue Planet and everything in between is based on open concepts where we can interop with existing networks, we can interop with existing technologies and products, and this allows us to support both greenfield, which are new IP network builds, but also brownfield, which means implementing this technology into existing networks. It's very much automation driven, and this is driven by real-time telemetry and streaming data, and implemented using a lean IP protocol stack. So the IP protocols we do support are the ones that customers need. The only thing we've done is we've not included IP protocols that haven't been worked in decades. So I just have this last chart, and then I'm going to pass it off to Nihar, and he's going to look at the more technical side of segment routing and adaptive IP. So I talked to you about the business parts, why customers I've talked to are looking at these new technologies, automation, open, programmable infrastructure, and Nihar is going to talk to you about how it actually works. And part of the key benefits that are supported by adaptive IP is segment routing. And this is standards open-based, open standards-based segment routing. And if you look at the three key benefits, get a lot of background noise here. If you look at the three key benefits of segment routing, it's around optimizing the network, simplifying the network, and improving the scalability of existing IP MPLS transport networks. So the easiest way to improve the agility and the cost effectiveness of your network is to simplify it, right? Remove a lot of that complexity. We talked about removing unnecessary protocols. That leads to some complexity reduction. talking about converging to optical and packet layers and automation and intelligence, segment routing in itself allows you to do 3 of these as well. So if we look at segment routing, how does it optimize? It's better utilization of existing network assets. This gives you a better overall network cost structure. These are the business benefits. Nihar is going to talk to you about the technology benefits. Simplify the network, you can lower the operating costs, and this accelerates your time to market for new revenue streams. It's much easier to bring new services to market when your network is simpler, automated, and highly programmable. And then third, it's very much scalable. Once you've simplified your network, you can actually scale it much easier. So not just easier in terms of lower costs, but just easier in terms of time to market. And simpler networks is a key benefit. So it's not one of the sexier topics, when you talk about networking, simplification, but it's actually the key goal of most network operators around the world. They really do need to simplify their network. And with that, I will pass it off to my colleague Nihar, and Nihar is going to talk to you about segment routing and Blue Planet automation. So Nihar, up to you.
Yeah, thank you, Brian. And just a quick sound check. I hope I'm loud and clear to all.
Yes.
Yep. Yes, audible, very clear.
Thank you. Thanks for that. So before kind of diving into segment routing details and how Ciena Blue Planet automation platform enables the closed loop framework that Brian just shared, let me spend a couple of minutes in defining some of the advantages that. So Brian, have you transferred the? So let me kind of just bring up some advantages, right? Some big ticket technical advantages of segment routing, right? And the first and foremost, of these advantages that comes to anybody's mind, whether it is a consumer that is an operator or it is a developer, which is an OEM, is basically the simplicity that it brings. And that kind of lured, the users like yourselves, the operators and the vendors alike to prefer kind of segment routing over traditional signaling protocols such as LDP or RSVP-TE for that matter, right? And we'll go through the detail, some of the details as to why not LDP, RSVP-TE, and why segment routing, right? And we'll also discuss some of the other advantages as we go along. And the simplicity itself can directly translate into the capex and opex spending that Brian shared as kind of burdening the operators today, right? And you have already have heard quite a few of the business benefits of a leaner and optimized way to connect the networks, right? So the next, and of course, why would I call it simple, right? So the fundamental question would arise as to why we call segment routing simpler than the traditional routing protocol. Now, first of all, and where we probably can relate as the networkers, I know there are architects, and you could be a decision maker in the network, you could be an engineer or operations, you could be coming from the operations team. And the first thing that you could be probably able to relate is the way LDP and RSVP deployed, it requires a lot of complex configuration, right? Anybody who has worked on LDP and RSVP-TE, I bet can relate it much, much better, right? And they know what I'm talking about right here. And the second point is the complexity of the configuration and the deployment as substantially been taken care of in segment routing, predominantly because you don't have n number of nodes to go and configure. Here it is just one single node where segment routing is configured is the source router or the originating router, right? The second big advantage or second big factor that contributes to the simplicity of segment routing is basically it significantly reduces the state overhead, right? Like LDP and RSVP-TE, you got to maintain the state of the network across each and every node. Doesn't matter even if it is a transit node, right? Where it is not, really catering to the traffic manipulation or traffic behavior. It's just a transit router, but still you've got to maintain the, state of the protocol. And in segment routing, this is taken away substantially because it's now only the head end and the tail end, right, that maintains the state of the network. Nobody else or no transit router in between needs to maintain any state unless until explicitly specified. Okay. And this also brings in another side effect, positive side effect rather, is that it brings down the convergence time substantially, right? So the ever-arching ambition that has been there for, since I've been in IP like 10 years, and I think all will agree here that 50 millisecond has been the ambition of operators to, converge the networks, particularly from a control plane point of view, which so far has been, somewhat achievable, but not quite at 50 milliseconds because there are other loops, other issues that are prevalent, and I'm going to talk about them as well. Now, segment routing definitely made it possible to reach at that convergence level. So one of the factors is, of course, because of the reduced state in the network. Okay. The other factor that also brings in, the advantages of SR is the scaling part of it. As Brian just mentioned about the scaling part. Practically, when we design networks from an RSVP, TE, or LDP standpoint, we have seen the scaling that arise, right? Whether it is maintaining the state, whether it is the mess of LSPs that we have to create because of RSVP, TE, that goes to the usual defined problem N square issue, which is basically the complete messed LSP network that we have to create when we are using RSVP, TE. Kind of restricted operators to use these protocols extensively, and that's where there was there was a hindrance, or there was a lacking of confidence in these protocols to be deployed across the network. So then customers, operators started choosing one area of the network versus other, which protocol goes where, right? Those are the kind of decisions that needed to be taken because of all those scaling issues in this protocol, traditional signaling protocols like LDP and RSVP. From a traffic engineering point of view, I think this is one of the biggest attractions why SR is being preferred today, because SR allows a very efficient way to do traffic engineering, and because it's driven by flexible policy definition, where we can define the way we want our traffic to be engineered across the network, right? And this also can be on demand. And when I say policy, a policy could be, for example, as simple as could be a tuple, which could define, okay, this is my head end and this is my tail end. And here is the number of constraints that needs to be built into the particular, path that I want to build. And those constraints could be, for example, a low latency path, could be a high bandwidth path, for example, or could be any type of constraint for that matter, right? So on demand, flexible policy definitions is what it makes it better than RSVP or LDP so far as traffic engineering is concerned. The other advantage with SR, particularly when we're talking about the protocol feature advantages, is the ECMP, equal cost multipath ability. Now, equal cost multipath ability is normally a standard, protocol that was defined outside the boundary of a signaling protocol, which means in traditional routing world, we see, you have RSVP, TE, you have IGPs running, you have LDP running, and then you have ECMP running. Now, every protocol that want to leverage ECMP's ability to load balance traffic and, use or load share traffic across multiple links, they need to align with ECMP logics or ECMP algorithms. Now, that was really a complex task, particularly when we're talking of signaling protocols like RSVP, TE. It's not that they have not been deployed, but those deployments have been really complex, right? Complex configuration steps, complex or non-optimal results, right? And that's where ECMP, which is now natively inbuilt into SR, helps our providers or helps customers right now to deploy ECMP much more effectively and much more optimized, right? So being native, it does not really now need to have additional configuration or additional, complex steps to align with ECMP logic, right? So SR now natively support ECMP. Now, coming to the convergence, which I just hinted a minute before. Now, from a high availability perspective, one of the most striking features that SR brings on is its TILFA, or topology independent loop free alternative, feature of protecting or providing 100% failure coverage across the network. Now, let me just spend a couple of minutes explaining what did I mean by that. Before, no, currently the networks, if you look at LDPR, GPT protocols, traditionally the way the convergence occurs is through implementing FRR, fast reroute mechanism, whether bypass technique or whether node reroute technique or whatever it could be, right? So FRR definitely was better than the earlier protocols, purely depending on IGP and BGP. Now FRR brings in certain advantages by pre-assigning the redundant path across nodes and across links, but that still did not quite meet the requirement of 50 millisecond protection. Plus, it did not cover the entire spectrum of the network, right? It did not provide 100% coverage. There was still issues of optimizing the path redundancy. Now, LFA and RLFA, loop-free alternative and remote loop-free alternative. These are the two predecessors of TILFA, which is now with SR. Now, LFA, RLFA was definite improvement on FRR, but they still quite didn't reach that stage, in the sense that, yes, there were improvements, but again, we could not really cover the entire spectrum of the network. That is, 100% coverage was still a dream, right? There were issues with depending on the IGP metrics for rerouting traffic, and that kind of resulted in micro loops. And micro loops now could result in suboptimal rerouting of the traffic, even if we have LFA and RLFA deployed. Now with TILFA, we substantially got away with this micro looping issue as well, which means now we got 100% coverage and we got our dream millisecond convergence of 50 milliseconds, right? That's the kind of high availability that it brings in. And of course, SR also supports protection at node level, whether it is link level or whether it is shared resource link groups, right? Multiple links, right? So this is from a HA point of view. Now, other pillar or other bigger advantage, or one of the biggest advantages of segment routing is it's closely aligned with the future outlook of IP routed network. So we have been talking about software-defined networking, network function virtualization, which are definitely going to be the major pillars of 5G rollouts. And that's where segment routing closely aligns itself with the programmability aspect or the software-defined networking aspect, which means that segment routing supports SDN controlled environments, which means that segment routing can be controlled, or the IP routed network using segment routing can be directly controlled by the SDN controller as an external controller that is controlling the control plane of the network, or could be manually operated. So both the ways are supported. So the programmability aspects are inbuilt into segment routing. Okay. Now I'll discuss a bit more in detail as we go to the next slides there when we're talking about the programmability aspects. The last but not the least is the flexible algorithm. Now, flexible algorithm adds the kind of existing capabilities that we discussed of segment routing traffic engineering. What it does actually is it defines another prefix segment, right? Not the traditional node prefix segment or IGP prefix segment, but it defines another prefix segment in segment routing, which is user definable and customizable, which means that segment routing by itself offers the flexibility to the users of that protocol to define its own way of defining traffic engineering. That means you as a customer or I as a vendor can develop my own algorithm to have traffic engineering influence in the network. So that is the kind of flexible algorithm scheme that segment routing offers as well. Okay. Now, why I'm talking all of this? Because these are important tenets of segment routing, why segment routing is preferred, and why Ciena as a company, we also, took segment routing as one of our major blocks of our adaptive IP vision. Okay. And last but not least is its unified fabric approach, right? as I said before, we had this idea of protocols playing in a hierarchy of a network, right? So if we go back a few years back, a few years down the line, we could remember that RSVPT, when it came new, people really preferred RSVPT for its ability to provide FRR, that is high availability, and also traffic engineering. But it also came with a penalty, right? With the scaling issues. So slowly, as LDP started taking its hold and network grew at the X level, people started migrating from RSVP and just restricted it to the core, and then LDP took fan in the access, right? Now, today we see these networks mostly across board, where LDP is access and somewhere RSVPT running just at the core. And then we have to have LDP running over RSVPT in the core. So you see there are multiple steps, multiple challenges here in order to interoperate between LDP and RSVPT. Then we have to run LDP over RSVPT. So these are the kind of complexities that we dabble with today, right? With the islands of protocols that are running. Segment routing promises an end-to-end, unified architecture, whether it is access, whether it is the metro, whether it is the core, or whether it goes into even the data center. So that's the kind of unified fabric approach that segment routing provides. Okay, and one of the biggest reasons and the reason why it could do so, because it can interoperate with every existing legacy routing stack, whether it is OSPF, ISIS, BGP, and some improvements with BGP like BGP link state, right? Since it depends on it can work on legacy and it can work on the future-oriented networking protocols, it can be accommodated or it can be aligned with any hierarchy in the network, right? So that's where the unified fabric approach comes with segment routing. So with that, I think I would like to run a poll. Shubhendu, if you would just like announce a poll here on the slide. Okay, so having just described a bit on the segment routing, I would like to know from you, do you still think, or do you think, not still, do you think segment routing is becoming the mainstream routing technology for service provider in next 12 to 24 months period? What's your take? You have about a minute to respond to that. And I think this is very important for us to know your view, because that's where we have been following across the world, across our customers, across our peers in the industry. And that's where we kind of brought in segment routing as one of the major blocks in our architecture. But nevertheless, we'd like to hear from you. What's your view in this part of the world? All right. So, wow. So this is kind of expected, but not 97%. This kind of overblown. Well, I agree. I think everybody today knows what segment routing is and why segment routing is going to be the mainstream routing technology over the next couple of years at the max. I think every customer today is deploying it in bits and pieces of the network, in parts of the network. Few are already doing lab trials with this technology, and as we move into the 5G and expanding our access networks in this part of the world, I think segment routing is going to be the de facto implementation standard. That's also our take. Thank you. Thank you for the poll results again. So moving on to the next. Moving on to the next, I'd like to spend a few minutes now explaining Ciena's Blue Planet closed loop automation framework. Now, this very closely aligns with what Brian shared a few minutes back, the circular vision of closed loop automation framework, right? That adaptive IP vision. Now, in that vision, major, except the programmable infrastructure that you saw, which is very instrumented and provides telemetry to the higher layers, Every other component in that framework comes from Blue Planet closed loop automation platform, which you see here, right? So what you see here on the diagram is basically an abstraction layer, the blue colored one, between the network domains and the application layer, the business application layer. Okay. Now on the infrastructure side, what we see different types of networks or different domains of networks. We see a telco cloud, we could see a private cloud, we could have SDN controlled WAN, we can have a software defined network, we can have legacy WAN, and we can have a traditional packet optical network. Okay. Now this is what we call a multi-domain network. Now in the multi-domain network, on top of it, we have is a Blue Planet abstraction framework. In that abstraction framework, we have multiple components that make that closed loop automation framework. Now I'll just very high level, I'll just explain each one of them because they are very important when we're talking about closed loop automation framework. Just starting from the left, we have an inventory framework or inventory block. Now this inventory is nothing but which discovers and displays the entire asset database, whether physical or logical. Okay, which provides this as a single as a source of truth to the rest of the components in the Blue Planet framework. The difference of this inventory versus the legacy traditional inventories that are there in the industry today is that this can also act as a federated inventory system, which means it can actually collect data from multiple sources, whether it is legacy inventory database, whether it is the network itself, whether it is the NMS, whether it is a very rudimentary database that has some data available with it. So it collects data from every source, reconciles the data through discrepancy management, and provides the best possible real-time asset view to the higher layer systems and to the user. So that's the inventory base. Now, why is this required? Right? Because this is the most neglected piece in the in the OSS BSS space and also possibly in the OSS BSS orchestration layer as well. The reason is when I have to do a closed loop automation, I really need to depend on a source of truth. Either I myself become a source of truth, being an orchestrator or being an activator, or I need to depend on a source of truth, on a single source of truth. The single source of truth provides the required data to the orchestration to act upon, right? Once any service or any activity needs to be orchestrated or done in the network through an orchestrator, it needs to know the exact state of the network for which it would require to inquire with the inventory, whether that state is true or false. And based on that, only can any service or any activity can be performed in the network. So that's why inventory is a very important component in the Blue Planet framework. The next component itself is the multi-domain and NFV orchestrator. Now, this is the core of our platform here because this directly interfaces the network for operations and for activation purpose. Now, every activation or every orchestration that has to be done in the network has to be done through the orchestrator. The orchestrator role is to automate a workflow end to end when activity is requested from a higher layer, right? Any activity that is requested taken up by the multi-domain orchestrator as an intent, it breaks down the intent further and then delegates that activity to the respective underlay infrastructure, right? Either directly to the network elements or to the EMSs or NMSs or SDN controllers for that matter. Then we have an assurance system, which is also part of the same Blue Planet automation framework. Now, the assurance system plays a bigger role when we talk about closed loop automation framework. Now, closed loop automation framework is nothing but what can be simply explained as a self-healing, self-optimized network, right? So if there is a fault occurs, right, the fault is diagnosed, the fault is identified, fault is diagnosed, fault is analyzed, And then there has to be a preventive or reactive action that needs to be taken in the network. And that's kind of a very simple example of what a closed loop automation activity is. Now, from that angle, from that view, we have a very efficient and optimized assurance system, and that is also having the capability of doing analytics in it. Okay, so we do have our analytics platform embedded with our assurance platform as well. Okay, the last one that you see is route optimization and assurance. Now, route optimization and assurance actually is very, very tightly related with segment routing, because it's very specified and very particular tool for IP MPLS network. What it does, it provides real-time visibility of your IP MPLS network control plane, analyzes the forwarding plane or the traffic based on user-defined constraints. It could be bandwidth, it could be link utilization, it could be latency, and so on and so forth. And then it further correlates the traffic pattern with the control plane to provide a deeper insight into the network, including, for example, root cause analysis of a particular issue. Now, how does it do it? How is it different for that matter, right? So ROA, it's actually a virtual router, right? It sits in the control plane of the network directly. It peers with your IGP, ABR, and ASBRs. It peers with your BGP routers with IBGP peering, and then learns the entire control plane. The difference it is only learning. It does not pass any update from itself to the network. It just sits there as a listener in the control plane. So that is how we have the entire topology and entire database of the network, right? At the same time, it is also pulling from the network the performance and fault management data by the telemetry or SNMP. So it's also pulling data, right? It pulls data from forwarding plane perspective, from a device and node perspective, and then correlates this collected data, right, via telemetry or via SNMP with the control plane to provide a very consolidated view of the service construct. A service construct is basically a service constitutes the control plane as well as the forwarding plane. Now, if a service has some issues or service has to be analyzed, both control plane and forwarding plane has to be looked at. Now, either you do a manual analysis by looking into both of them, or ROA can do it by its own algo, right? ROA has that ability to correlate both of them and provide a deeper insight into the services layer. Now, that's ROA's job. Another bigger construct of the Blue Planet framework is how it interacts with the network southbound and how it interacts with the business layer on the northbound, right? On the southbound, if you see, it interacts with the network via something we call the resource adaptation layer. And the resource adaptation layer is responsible to provide communication to and fro from the network to the Blue Planet framework. Okay, so you can think it of as a communication agent sitting in between. All right. Now, this resource adaptation layer is very flexible in the sense that there are plenty of libraries already available with us. It can be developed flexibly, right? We allow development, by our customers. They can do it by themselves for a new resource adapter development through our software development kit that is provided along, right? Or can take help our professional services. On the northbound from the Blue Planet framework, we definitely added to the standard API-based communication with the northbound system, whether it is an order management system, whether it is a third-party assurance system, or whether it is a BSS system, and so on and so forth, right? So these northbound communications either can be standard open APIs based on TM forums definitions, or could be customized APIs as well. So this is kind of a high-level explanation of what Ciena's Blue Planet framework looks like. What are the different components? So namely, I summarily basically inventory, orchestration, assurance, and then route optimization and analytics, right? The four major components of framework. And then we have an abstraction layer that we call a resource adaptation layer that makes it, to talk to the network to and fro. And on the northbound, we can communicate with higher layer business and operation support systems using either standard defined APIs, or they could be custom APIs as well. Moving on to the next, let's look at how the current IP MPLS networks deployed today, right? So this is kind of a diagrammatic representation of what we discussed right now. So if we look at from left to right, we look at the access layer where LDP is deployed. Primarily, this is what we have seen and we see very frequently. Then we have aggregation layer, again LDP. When we come to the core, not all of them, but many of them still running RSVP-TE because of its traffic engineering ability, okay, and because of its high availability features. And then again, if we pass on to the right side, aggregation and access, we have LDP running. So the complexity here is basically LDP, LDP, LDP over RSVP-TE, and then again LDP, LDP, right? So there are complications in terms of the protocol interworking. There are complications in terms of how do we operate and manage those scenarios or operate those scenarios, right? Now, the way this is being done today is you have multiple vendors, could be, for access layer, you could be one vendor, aggregation another vendor, and core another vendor, possible, right? And for every vendor, you have different NMSs. For every NMS and every vendor type, you have specialized skills that addresses those configurations and execution in those networks, right? And mostly they would require manual processes to be brought in to configure and orchestrate the services in the network. What is done right now with Blue Planet automation is we bring in that intelligent automation software layer. Particularly when we are talking about segment routing, the two major components that plays a role here is the route optimization and assurance, which is ROA, which acts as a control plane participant in the network, which provides visibility into the SR network, segment routed network, which provides traffic engineering analysis into the network, and which can also provide the best optimized path recommendations for the network. Okay. MDSO plays a role here as an orchestrator. So every recommendation that needs to be deployed into the network, either explicitly or user-defined way, needs to be orchestrated through the MDSO, which is multi-domain service orchestrator. Okay. So here is what we have shown as our adaptive IP network on the middle. So that's where you see SR as a unified fabric here built on Ciena gears. Now, just to make one comment here that not necessarily for the intelligent automation software layer, it has to be Ciena end-to-end. It really does not matter. It could be any vendor. Again, I'm reiterating this factor. The higher layer of ROA and MDSO are agnostic to what vendor technology or what vendor is playing the role in the network here. Okay. Whether access, aggregation, or core. But this is to set up our adaptive IP vision. Now we have an end-to-end SR IP network built by Ciena. Then we have something in the middle called NCP that you see here is manage, control, and plan, which is the NMS or the domain controller of Ciena IP gears only. Okay. Now these three in coordination, make the intelligent automation layer for the SR network, segment routed network, ROA, NCP, and MDSO. So I have one question here. Maybe you can display that question, Shubhendu.
Yeah, we are displaying it. And just because of the technology thing, limitations of word is there, but I'll just read out the entire question for the benefit of the respondents. Do you believe that Ciena's segment routing architecture, complemented with Blue Planet closed loop automation framework, will drive the desired result of reducing network capex and opex and accelerate time to market for new services?
So the idea here is to, I know that this is a very high level explanation of what is Blue Planet automation framework, but however, I expect that you got a gist of what the automation framework is supposed to be achieving or providing you in terms of your closed loop automation vision, particularly in the context of Ciena's adaptive IP vision. that Brian shared earlier. Okay, fair enough. That's quite assuring.
Expected?
Yeah, so I would, yeah, of course, yes. And this is quite assuring that yes, people believe and understand that we could do this. Very good, and I'm very happy. Let's move next. So let me now drive one step further and go a little bit deeper into this whole architecture stuff, right? How this thing happens. Now, this is what do you call it? This is a very concise view of what we could do as an intelligent automation platform as Blue Planet for Sienna's adaptive vision, right? Now, below what you see, the cloud structure is Sienna's Adaptive IP network. It's a segment routed network. And the blue parts are nothing but Sienna's Blue Planet components. Now, let me go one by one. What you see on the left is basically the MCP is the domain controller that is controlling and managing the entire the Sienna's IP gears or IP deployment. ROA learns the topology from the network directly. As I mentioned, it directly plays a role in the control plane. So it can learn the topology and the services that are there directly. It has its own inbuilt path computation engine, PCE, to do IP path computation end to end based on the constraints that are defined. It monitors the IP network events and performance, right, based on the telemetry data it is collecting from the network directly, right, via SNMP and telemetry. And then it provides the analysis by correlating the collected telemetry data and the control plane that it has already learned, right? So it has already the analysis available with it. Now, MDSO on the right, what it does and it can, MDSO acts as an orchestrator, right? So every higher level intent that has to be passed on or executed in the network has to be passed through the orchestrator, which can break down the intent into multiple definable tasks, right, that can be executed into the network via either the domain controllers, via the SDN controllers, via the NMSs, or even directly into the network. Okay. Apart from that, multi-domain service orchestrator, I think I have already said that, but repeating it again, can learn all the layers, right? So here ROA is learning the layer 3 topology, layer 3 services, layer 3 control plane and forwarding plane. Whereas MDSO can learn the other layers, the layer 0 to layer 2, right? Although it can also learn layer 3. But here in this scenario, in our solution, it is learning layer 0 to layer 2. So anything that requires a multi-layer analysis, multi-layer orchestration would require MDSO, right? So MDSO can also learn the transport topology and services, receives all the network services and updates directly from the network elements or via the NMSs and their controllers. If when required to be, to create an end-to-end path, for example, MDSO queries ROA for the best path that it has created from its path computation engine, takes that path information, and then executes or creates that path in the segment routed network. MCP, as I just explained, is the SDN controller or the Ciena domain controller, particularly for Ciena. This is Ciena specific. It learns the entire L0 to 3 topology and infrastructure that is created on Ciena and configures and do a limited performance and fault management of the network as well. So these are the 3 major constituents of a segment routed closed loop automation framework right now. Okay. And based on this knowledge, let's move to the next, on the next step, how a network would really look like. So just what you could see here is a segment routed network, right? From left to right, you have, let's say, 3928, which is a Ciena IP router, which can be said, let's say A, and there is a destination router or the end node, which is J, which is labeled with 1606. Now the labels that you see here are nothing but the prefix segment IDs. That's how in a segment routed networks a node is being identified. Okay, so these are labels for the nodes in segment routed networks. Now, assuming a packet has to travel from node A to node J, right? What are the different nodes it has to go through are all defined at the originating router. No other router in between has to maintain any state of the network here or the path information here, right? So, for example, a packet has to travel from 1601 to 1606. The packet construct on A would look like this. You have the payload, you have the service level, then you have the destination prefix society SID, which is 1606. You see that yellow thing, I'll just explain in a moment. And on top that, you see that it has to go through 1604. That is another segment ID of a node in between. Now, why we do that? Now, this is exactly what traffic engineering means, right? We want the path to actually traverse via B, C, D, and then go via F to J. It should not be going via E. Now, that's our definition, and we want every traffic that has to go from A to J has to follow this path, right? And we define this via one is what prefix said, what node it has to pass through, which is 1604 definitely, where the traffic has to take a detour. And then we say, what is the immediate adjacent segment ID? Now, this segment ID is exactly the link that we are referring to. Now, here the segment ID that we are referring to is 205. Now, 205 segment ID or segment level refers to the connectivity between D and F. You see that black line here, right? Now, this is how we define the entire packet construct or the forwarding construct at the originating node, the source node. And that's why segment routing many a times is also called source-based routing. Okay. Now, this is very high level how segment routing operates. Of course, there are a lot of topology and architectural details that goes into it, but at a high level just to set our context and to understand how segment routing operates, I think this is good. Now, the point is, how do we automate the entire process, right? One is, of course, I can go into node A and define how a packet has to traverse from node A to node J. That is one way. Second, I deliberate this task onto my orchestrator or on an SDN controller to do it automatically. So how does that happen, right? Now, assuming that the base LSPs are created via segment routing already, and then I'm learning entire segment routing topology via IGP or BGP on the ROA, which is already participating in the control plane. And then MDSO is acting here, as I explained, as a orchestrator, as a configurator. And then MCP is the NMS, right? Now, all these different components here, whether it is MDSO, MCP, and ROA, they are talking to each other via open APIs. And in few cases, they have the, message bus, which is basically Kafka messaging that they implement in order to talk to each other. Okay. Now, how does this whole ROA influences the traffic or the LSP creation is something that we will see in the next slide. So here is again the same diagram that we just saw, right? We have a segment routed network. We have created an LSP from 16002 level all the way to 16010, right? Which is our destination prefix node. Now, this is just an example of how this closed loop automation thing would work, right? 16002 is where traffic is ingressing and 16010 is where traffic is egressing. Now, this is the LSP that traffic follows, right? And at certain point of time, the link between 16004 and 16006 gets congested. Okay. Now, since ROA is collecting all the telemetry data from the nodes, it could also now be aware, it gets aware of the congestion that's happening in the link. Now, how does it know that this is a congestion, right? That's a question. Now, this congestion thresholds are defined by user. You can define a base threshold. For example, if the link utilization exceeds, say, 60%, then you send us an alarm saying that the link is congested, right? Now, this is what exactly ROA would do. It would trigger a performance change alarm to the policy engine of MDSO. Now, the policy engine, policy subsystem that you're seeing here is shown differently, but this is actually an embedded component of MDSO. Okay. Now this trigger goes to policy subsystem saying that, there is a congestion in the network. Now in the policy engine, you define business rules as to what to be done if there is a congestion. For example, now your policy or your business rule could say that if this particular link is congested beyond 60% or 70%, then reroute the entire traffic via new LSP, right? I'm sorry. Using 1603, 1607, 1605, right? So that could be the policy definition that you could define at your policy subsystem. That is step 3. Now, MDSO would know, of course, via policy system that there is a violation and it needs to know about a new path. It yet does not know which could be the new path. So it asks ROA for a best path computation from 1602 to 16010. ROA runs its path computation and informs MDSO about the best path availability. And then MDSO at step 7 goes into the originating node and pushes that configuration in. Now here we are not pushing that configuration via the SDN controller or the domain controller, which is MCP, but it could well be the use case as well. MDSO talking to the NMS or pushing the configuration via SDN controller to the originating router, which is 1602. Now the end result is the rerouted or the reconvergence of path happens automated via this closed loop automation framework. Now here, in no point of time, user intervenes or user defines anything. It's all automated. Once the business rules are defined, the policies are defined, ROA identifies the violation and informs this to MDSO via policy. MDSO requests for a new path. Once a new path is identified, MDSO goes and provisions that new path automatically. Now, this is just one of the examples, one of the constraint examples where we use, for example, congestion as a mechanism. But at the same time, it could be, for example, latency. For example, it could be high bandwidth link. It could be, SRLG, preferred SRLG. It could be any type of constraint that could be brought into the scenario for a closed loop automated, deployment, right? So this is kind of an example. And with that, I would like to bring my session to the end. And I would like Brian to take over the control and summarize our entire discussion. Brian.
All right, thanks, Nihar. Appreciate it. So we're going to summarize here the presentation, and we'll open it up to Q&A. So I tried to provide you with an update or an overview of why the market is moving towards a different way to deliver IP connectivity, in particular leveraging automation and intelligence. Segment routing fits very well into that new architecture or that new paradigm, as Nihar just went over so eloquently. And also, there's a whole new way of building IP networks, and our version is, or our view is, it's the adaptive IP network solution. So it's basically built around 4 building blocks. So the first one is, this is the connect part of the adaptive network vision. So you do need hardware-based routers, you need optics and so on to carry the bits from one part of the network to the other. So we have a whole suite of purpose-built platforms. And when I say purpose-built platforms, is we have specific a new family of routers targeted for the 5G front haul, mid haul, back haul space. So not only are they open programmable routers, but they also support things like a network slicing, flex Ethernet, and all the timing synchronization capabilities that you need in a mobile network. So we have a broad selection of the purpose-built platforms and software. This is what is the connect part of the adaptive network vision. We also have, and Ciena is known for coherent optics. We have our new WaveLogic 5 in two versions. We have the Nano, which are pluggable coherent optics that will plug into not only our background noiser. Yeah, so these pluggable optics will plug not only into our routers, but anybody else's as well. And then we have the fixed WaveLogic 5 Extreme optics. We can go up to 800 gig from one part of the network to another. So this is the hardware-based programmable infrastructure that we have. Nihar just gave you a very good overview of the Blue Planet automation software. So this is what is very much different in the adaptive IP approach. We looked at not just the routers, right? We looked at optimizing the routers. We have a leaner set of IP protocols. It has all the protocol support that the new applications and use cases, and even the existing use cases require. We just stripped out the ones that people are not using anymore because there's just no reason to have them in the network. And then lastly, the journey towards the adaptive network, and in particular this use case of using that adaptive network vision to deliver IP, will require new skill sets, and we have a professional services organization that can help our customers and network operators move towards closed loop automation and all the benefits that Nihar just went over. One thing to keep in mind here when we look at the adaptive IP solution, it is very much driven and built upon the open concept. So you don't need to have all of these in your network, right? So if you choose to use our routers in your network and just our routers, let's say for 5G XL applications, that's fine. They are full-featured routers. If you'd like to use a coherent optics and somebody else's router, that's also possible. And also the Blue Planet automation is built around openness as well. And that's key because the management side or the software automation side will touch the end-to-end part of the network, which is typically, in every case I've ever seen, multi-vendor and multi-layer with different products and technologies. So this whole adaptive IP architecture is built around openness. You can pick and choose which part of this portfolio that you believe fits best into your network. And that's one of the key advantages of this solution. And it's also targeted towards brownfield, so existing IP networks, but also greenfield new builds as well. So openness is a big part. Now, if we just summarize the 3 key takeaways that we hope you get from this presentation, then we'll open it up to Q&A. The first one, the 3 building blocks of adaptive IP is openness, a broader and more secure supply chain. Automated, it's based on intelligent automation that Nihar went over. So this is the way to best optimize your network by having the network provide real-time streaming telemetry, and then you can use machine learning algorithms to decide what to do with that data. And then lean, using a slimmed down IP protocol stack, which gives you not only improvements in simplification of your network, but it also has less storage and compute on each individual router, which means lower costs as a whole. 2, it's an open architecture. You can pick and choose. You can build a best in breed network. One thing we've learned is that operators have their own views of what is best in breed. So this allows them to choose what part of our adaptive IP portfolio is best suited for their network, and then mix it, match it with third-party vendors to build what they perceive best in breed. And that will be built based on the target market they're going after and what's the performance they want to offer to their customers. And then lastly, segment routing. So we talked a lot about adaptive IP, providing automation and intelligence and simplification across the network. Segment routing technology, open standards-based segment routing, is being adopted for the 2 main reasons of simplicity and scalability. But it does also have key benefits as well related to advanced protection, which Nihar covered, the TI-LFA, and also advanced traffic engineering capabilities. And the traffic engineering can be decided at the edge nodes, or it can be in a centralized controller that we talked about, our PCE, or also in a hybrid approach. And this gives flexibility to network operators to decide where they want to deploy segment routing, how they want to deploy it, and how they want to roll it out over their entire network. So it could be a phased in approach. And most operators I talk to, that's exactly what they want to do. They very much are looking towards segment routing, as the poll today, 100%, clearly showed. But they want a phased approach. So they don't want to do an overhaul. They want to phase segment routing into their network. And that's a big advantage that segment routing, and in particular, our implementation of it, can be integrated with existing IP networks as well. So I'd like to thank you on behalf of myself and for Nihar for your attendance, but also for your attention. And now we will go into the Q&A. And just as I catch my breath, maybe Nihar, you can take the first question.
Sure.
So, thank you, Brian. Thank you, Nihar. This was a lot of information, and I hope the participants got their answers. They still have some questions. I'll just read it out. Is adaptive only for few builds, only for new builds, or is it compatible with existing IP networks builds. Should I read it again? Am I clear?
No, I think I got you. I got you. And I really appreciate and understand. Thank you for the question. It's a very good question. And in short, this is not for new. This can be very well be applicable for any brownfield deployment, right? And as we know, there are new networks are not every day coming, right? And the adaptive IP is visioned, and the way the framework has been created, keeping in mind that we have to have this adaptive IP vision employed and deployed in existing brownfield networks as well. So yes, this is meant for existing and new both. I hope I answered the question.
Right. So there is one on, okay. You touched upon the power consumption concerns. How can adaptive IP enable us to meet our green obligations?
Yeah, that's a really good question, and it comes up often with customers. One way to reduce the power consumption is to optimize the network utilization. And we've seen networks where customers have overbuilt one part of their network and underbuilt another part of their network. And very often, if you don't have a good view of your network holistically, which is what our Blue Planet ROA would provide, you're probably overbuilding your network. And overbuilding means putting in too many routers, too much capacity, too much capabilities in your network that you don't actually need, and that translates directly into unnecessary power consumption. So if you can optimize the assets that you have in your network, that's a key way to be able to reduce the overall power consumption. Hello?
Hello, Shubhendu? I can hear you, Brian.
So I'm clubbing them. Yeah. Can I share the third question?
Sure.
Am I audible?
Yes.
Yes, you are. Go ahead.
Yeah. So there are two questions related to Blue Planet. Whether third-party vendor equipment can be managed by Blue Planet, and the second one is I wish to know the practical implementations of Blue Planet automation features.
Fair enough. So answering the first question, yes, it can work with any third party or any other vendor equipment. And the reason I briefly explained is because of the flexible resource adaptation layer that's in between the Blue Planet framework and the network. So via resource adapters, we can actually technically and literally can work with any third party vendor and with any layer. It could be a layer 1 vendor or layer 2 vendor or layer 3 vendor. It really does not matter to us. We can work with literally with any vendor, any type. That answers probably my first question. The second question, I think it would require a more detailed discussion, but there have been n number of deployments, and I would urge you to log into Blue Planet website, blueplanet.com, and you're always welcome to reach out directly to me. And there are n number of case studies that are available, both from individual componentized deployment like only orchestrator or only inventory, only ROA, and you'll find also closed loop automation examples in the net. So there are practical deployments already there. So you can take you from there, or you can reach out to me anytime you wish for more detailed explanation.
Do we have time? Yeah. Do we have time for one or two more questions?
We can.
Sure.
Okay. So there is one, since the originating router contains the destination router information, how logic will be built to overcome the originating router malfunction or failure?
So segment routing is primarily dealt with source routing. So you have a source where it is assumed that the traffic is ingressing, and you have an egress router where traffic is supposed to be egressing. Now, if your ingress router itself fails, either you have multiple ingress points, that is another ingress router where you can originate your path, right? Or your entire flow is, done with. It's failed because the ingress router is where traffic is ingressing itself. So if you take out that node, where would you inject the traffic? That would be the first question. So the answer to this is you got to have multiple ingress nodes, right? So if one ingress node fails, it is via either the SDN controller that could define which could be a secondary ingress router or secondary ingress point from where the LSP has to be originated, right? So that could be done by SDN controllers, in the network deployment. But fundamentally, the ingress router is the source. So if the source fails, of course, fundamentally you lost the entire path. Brian, did I answer that, or you would like to add anything here?
Yeah, I think you covered it very well. Yeah, I have nothing further to add.
Okay.
Great. So there are two questions, and I think we can take it up. One is, why is streaming telemetry important for tomorrow's IP networks?
Yeah, I can take that one, and then maybe Nihar, if he wants to add. Streaming telemetry, I think, is critical to not just IP networks, but even at the optical layer as well, because what it allows for, if you're going to use automation and intelligence, you need to feed it reliable data, but more importantly, you need to feed it timely data. And by having streaming telemetry, you can actually continually have the network poll. You can poll the network, or it can push the streaming telemetry into that analytics algorithm, and then you can perform real-time view of what's going on in the network, what has to be done. This could be optimization, it could be protection switching, it could be, routing traffic around congested points. The only way you're able to do that reliably, because networks change over time, right? Services are created and deleted, router ports go up and down. The network is a dynamic, living, breathing organism. The real-time telemetry provides the necessary timely information into that analytics and intelligence, so you can perform timely insights.
The other, just one point to add here to this answer Brian has given, the explanation is telemetry is relatively the most efficient way to export data into the analytic layer or the higher layers, right? Earlier, what we used to do is we used to collect data either by sampling mechanisms onto another module, onto another hardware, so that my CPU is not overloaded, right? To save the CPU cycles on my router, process cycles on my router, we used to offload it, or it could be at the best be via SNMP polling. Now, both of them prove to be either expensive or inefficient. And telemetry, for example, using GNMI proves to be the most efficient as of date to supply data from the nodes or from the network. Yep. That's all. Next question, Shubhendu.
Great. I think we have just time for one more question, and because we already overshot the time. So why is 5G so important now? There's so much noise about 5G coming in, though it's still some distant away. So why is 5G so important to how tomorrow's IP network are designed, and how will it change it?
Yeah, that's a good question.
Yeah, I think Brian, you got to answer the maximum of, just from an India context. Just add me 1 point to the start and set the context here. Yeah, from an India point of view, 5G looks little far away. You're right, whoever asked this question is. Yeah, it looks a little far away, but nevertheless, that far away could come very fast. What it means is it could be a leap jump, right? In another 1 or 2 years' time. It's possible, because the way data is exploding, the way things are changing, 5G could be inevitable for operators to adapt. So it could be a leap jump. And now I'll let Brian to give his global perspective of why 5G is important. Brian, please.
Yeah, absolutely. Thanks, Nihar, for the regional context. Many countries are in the same boat as India. They're taking a wait-and-see approach, and that's been the case for every generation of new mobile technology. I don't think 5G will be any different. But in particular, the IP part, IP uses IP connectivity to the cell sites, just like 4G did. But the difference, there's a lot of new features in in 5G that will enable increased IP connectivity. For example, cell sites can talk directly to each other rather than having to go back to a mobile switching site. So that gives you more IP requirements at the cell sites. But more importantly, if you look at small cells, 5G using the millimeter wave band, this is very high frequency, gives you very high capacity, but it also gives you much shorter reach. And what that means is if you want to leverage the millimeter wave bands to provide the extreme levels of download speeds that 5G promises, you have to deploy 5-10 times more cell sites than you have today, and each one of those cell sites is an IP endpoint. And that's where things like automation, intelligence, self-optimizing networks, and all the other features that Blue Planet enables, for example, is a key part of 5G. So 5G is all IP. It's a lot more endpoints, and it also gives you new functionality that requires increased IP capabilities within the cell sites, more so than what you have today.
All right, I think we've done the question, Shubhendu.
Just one for me. So as a CIO, since you mentioned adaptive network and the 5G and all, what are the two things you would advise the CIOs to, 2 steps to take and to the run up to the 5G network and the entire Industry 4.0 era?
Do you want to start, Nihar?
Yeah, you go ahead, Brian.
Yeah, I mean, yeah, it's a really good question. I mean, it very much depends on what's your starting point and what's your desired endpoint. We say at Ciena very often that everybody's on a unique 5G path, and that's actually the case because every operator that I've talked to, and this could be a mobile operator, could be a wholesale operator that provides connectivity to cell sites for the mobile operator. Everybody is at a different starting point. They all have a different destination point. So truly plan out your network from the start. And if you're going to implement automation, intelligence, and segment routing, you have a big competitive advantage over your competitors who are going down the traditional legacy way of building out IP networks. So right away, using automation, intelligence, segment routing, you've simplified your network, you've cost reduced your network, and you made your network far more agile. And that's a big competitive advantage, but you have to plan it properly. And the advice I would give back to any operator is really understand where you want to go, who your competitors are, and how fast you want to get there, because that is ultimately going to dictate what path you should choose on your 5G journey.
Perfect. I think you summed it well, Brian.
Okay.
Right, sir. So if there's nothing that Nihar has to add, so let's call it a day for the webinar today. And thank you, Brian. Thank you, Nihar, for taking your time for the webinar, despite the time difference and all. And I thank you everyone who joined us for the session this late evening. It was a pleasure learning about the adaptive IP approach and the innovative solutions that offers the essential IP capabilities which is required to support the new applications while allowing network providers to benefit from the cloud-like scale, openness, and intelligent automations, etc. So in case participants still have any doubts and questions, you can reach us or to the speakers. We will also be uploading the recording of the session as an audio on demand on our YouTube channel so that you can listen to it again or share it. Please send in your questions to npanda, NPANDA @ciena.com. That is npanda@ciena.com. And please don't forget to share your feedback on the form that will be soon appearing on your screens. And last but not the least, a big thank you to our partner Ciena for supporting this technology session. With this, I close the session. Stay at home, stay safe, and keep joining our webinar series. Good night.
Thank you. Thank you all.
Yep, thank you.